Hi, my name is Ellie Markert, and I'd like to talk to you guys a little bit about something that I'm really interested in, which is RSA encryption. I've always been really interested in encryption and code breaking and stuff like that, and I've recently become really passionate about computer science and programming. And I was recently able to combine those two fields when I wrote a prototype of an RSA encryption program. RSA encryption is named after its founders, Rivish, Shamir, and Edelman of MIT, who first developed the crypto system. RSA encryption is a type of public key cryptography, so it works with a public key and a private key. The public key is a number that's known to everyone, it's what's used to encrypt the message, but the private key is a number that's used to decrypt the message, and it can be found in relationship to the public key using an extended Euclidean algorithm and some other steps. And that number should be kept secret and should only be known to parties who are authorized to read the message. RSA encryption is based in modular arithmetic. So basically a modulus is the remainder you get when you take a quotient. So if I did 7 mod 3, I would get 1 because 7 divided by 3 is 2 with a remainder of 1. And in the same way, 2 mod 5 would be equal to 2 because 2 divided by 5 is 0 with a remainder of 2. For RSA encryption, we'll need to use a very large square-free modulus, which we'll call n, and n is the product of two massive prime numbers. In my encryption program, I use two 50-digit primes, but basically the larger the primes, the more secure the encryption is. We'll use that modulus n in our encryption formula. So to encrypt your message, you'll need to take c, which is the numerical value of your message, raise that to the power of e, which is the public key, and then take the modulus of n. To decrypt the message, you'll need to plug that value into the decryption equation and raise that to the power of d, which is the private key, and then take the modulus of n, and that'll give you back the original value of your message. RSA encryption is very, very secure, and it gets its security from the extreme difficulty of factoring such massive integers. Basically, the longer your key is, the more secure the encryption. Ideally, you'll need your key to be at least 2048 bits to make sure that your information is safe. Right now, with our computing powers, it would probably take a supercomputer a few hundred years to sort through all the factors and break the encryption. Now, if we are able to develop a quantum computer, that'll change the game a little bit because it'll be able to work through the factors much, much faster. But right now, with today's standards, RSA encryption is very secure, very safe, and very widely used. Thanks for listening. I hope you guys enjoyed learning a little bit about the topic that I love.